Hey guys, welcome back to the channel. Okay, let's get going with this. It's been a minute since we've done a programming video, and I apologize for that. I wanted to get this up a lot sooner than I did, but I kind of wanted to on my scrap program, or my initial program, get it working so that I got a triangle on the screen. I haven't quite gotten there yet, but I'm pretty close. But I really need like another hour or two of coding on it, and I should be able to get it done. I just haven't had time to get it done. But I think I want to get done, at least start the asset initialization part before I forget what I did and why I did it. So let's get going with that. So, okay. At the moment, we've got the program set up so that it finishes off the pipeline initialization. We get the right white screen. We're fine here. Everything's fine. There are two parts to initialization. There is initializing the pipeline objects, and then there's initializing the assets. So I'm going to do a slight structural change here, and I'm going to go under here. I'm going to say bool initialize pipeline, and we'll do we'll need to pass in the window. Gosh dang. Okay. And that should be fine. Okay, let's go back into here, and where we have it set up as initialize, I'm going to change this to initialize pipeline. So that this is specific to initializing the pipeline. Okay, now I think what I did when I did this, let's see, then this is enable debug layer, which is, yeah, okay. So then I'm going to come up here and take this initialize function, and we're going to redo it. Stick this up here. That in there. Initialize direct3D pipeline, and this is going to be here. Initialize direct3D, etc. Okay. All right. The reason I'm doing that is because, like I said, there's two parts to initializing direct3D. There's initializing the pipeline, and there's initializing the assets. So this is going to be specific to initializing the pipeline, and then we're going to do another one for initializing the assets. Let me just take a quick look at my other thing just to make sure I'm doing this all the same, but it should be. Okay, so here we'll just say if not initial. Tell you what, just because I don't want to screw up the spelling, because I will. Yeah, window. Return false. Okay. Okay, and then we're going to say if not in same thing, initialize assets. And I don't think we need to pass anything in there yet. Well, if we do, we can change it. We don't need the brackets. We're just going to return false, like such. Okay, now it doesn't know what initialize assets are. That's fine. So we're going to come down here. Let's just make sure I'm going to stay consistent. Yeah. Asset initialization functions. We'll just say bool initialize assets. Such. Okay. And there, it's happy with that. All right, very nice. Now let me just see where we are. Okay, yeah. All right, let's head down to the bottom. The last thing we did was create the command list allocator, and that's still a pipeline function. So we're going to start in with the assets. Let's just grab this. drop it in here. Initialize the D3D assets. Okay, very nice. We'll just make this part of the class and lose that, and there you go. Okay. So basically it runs, what's going on here? Size is uninitialized. Okay, yeah. Right. Descriptor size. Yeah, we didn't initialize that. We should probably do that. Just to get rid of that. Equals 0. That should go away. All looks good. Actually, this really should be on top. It's first in my list. Okay, that's fine. All right, let's continue on. So yeah, it works pretty much the same. It works exactly the same. The only difference is now we're calling initialize assets. So initialize will come in here, initialize the pipeline, and then we'll call initialize assets. And then down here is where we're going to start initializing our assets. Okay. So let's get started with this. What we need to do to initialize the assets is first we got to create a root signature. So let me see where I did that. Okay. So let's just pop in a new function. And we're going to say create the empty root signature. Okay, so we'll call that function. If not, create root signature. Stuck an extra W in there. Create root signature. And then we'll just do stuff. I really got to get rid of these debug string things. I don't like them. Okay. Initialize assets, create root signature. Okay. So over in here, we're going to create that function. So same thing, bool create root signature. And again, stuff. What the hell? Why would I put a space? So yeah, guys, this is just Direct3D stuff that you got to do just to make sure Direct3D works. It needs all this kind of stuff. We'll use it as we're going through things, the coding. So don't worry too much about it at the moment. All right. So we're going to create an empty root signature like such. Okay. To create a root signature, there are basically 2 steps. There are 3 steps, really. We need a root signature, and for that we're going to use a helper function. So C D3D12 underscore root signature description is what we're after. Root. There it is. Signature description. There you go. We need to describe the root signature. So we're just going to call this root signature desk. I keep wanting to misspell that word. All right. So let's start by clearing it out. And then we're going to say root signature desk dot init. All right, a bunch of parameters here. So first of all, there's two of these. I think we're going to use the second one. I think that's what we're supposed to be doing. So no num parameters. The root parameter is going to be null pointer. So we're just creating an empty one, guys, basically. So the u, see, we're here, number static samples 0. I think we could actually just use the defaults at this point, but I'm not sure. Null pointer, yep, null pointer. And then the root signature flags are going to be this big old long thing. Hang on, is it in here? No, this is why we can't use the default. Okay, so D3D12 root, and I've lost it now. Signature flag underscore allow input assembler input layout. Hopefully that's right. I didn't misspell it. What does that mean? Beats the heck out of me. I don't know. We're just creating this root signature, right? That's the description. So there you go. Okay, so we want to set that up. So failed D3D 12 serialize root signature. And then we pass it in that description that we just gave it, root signature description. Then some parameters. So this is going to be the version. So D3D root signature version 1 is what we're after, comma. Then we got a blob, which is going to be, do I know what this blob is? Oh, this is going to be the signature itself. So, okay. So underscore signature. And then we got another blob for the error. So we'll just put in error. Okay, now it's not going to know what those are, right? So let's set that up. Com pointer id3d blob signature, and com pointer id3d blob error. Put the wrong thing here. Okay, there you go. And then we got a failure condition here. So let's go ahead and drop that in. Create root signature. And this function is serialize root signature. Okay, there you go. So basically what all we're doing here is we're creating a root signature, and we're associating the description with that signature, right? If there's an error, there's a whole blob thing for it. At the moment, we're not bothering with it. We're just gonna use the fail condition to return our little thing. But later on, if we want, we can actually do something with this error, and I may do. It's probably not a bad idea. It'll give us more information, but let's make sure that everything's working. It is not. Oh, I haven't returned anything. Create root signature. Okay, let's try that. There we go. It's fine. So it's working. There you go. So yeah, we're doing all this work to create a root signature. What is a root signature? I don't know. We'll find out when we do it. Okay, so let's go ahead and actually create the actual root signature. So this is from the device, and we're going to create root signature. We need some functions. So the node mask is going to be 0. The blob with root signature is going to be from the signature that we just created. Signature, is that right? Signature, yeah. This is going to be get buffer pointer. And then we need the blob length in bytes. So we're going to say signature get buffer size. That'll be the size of the buffer. Then an ID thingy. So this is going to be IID, PPV, ARGS, address of root, signature. Okay, so it doesn't know what this is, right? Yeah, this is the thing that we need to actually keep. This is what we're going to be using later on when we're actually using the root signature. So what we're going to do is I'm going to come down here and say we're going to need asset objects. So let's set up some asset objects. Let's set up some of those, and this is going to be a com pointer to a ID3D root signature. Root signature. There you go, like such. Okay, and then again we have a failure condition here, so let's just drop that in. We'll drop this in here, and we should be good. I think. Why doesn't it like this? Oh, what are we doing here? Oh, these are functions. Derp. Sorry. That's why it's unhappy. There you go. That's better. And there you go. The root signature has been created. We created an empty root signature, and we've got it stored. And everything should be good. I think we're fine. Very nice. Okay, there you go. We created our root signature. We'll be using that to draw triangles, apparently. Again, guys, it's a lot of steps in D3D, and honestly, I don't know what they're all for. I just know we're going to be using them. We need a root signature later on to do stuff, so we'll figure out exactly what it's for when we actually go to use it. So, okay, one more function that I want to get going with. Putting in weird stuff. Create the empty root signature. Okay. For today, and it's kind of a long function. We're going to be creating the pipeline state. So I'm going to come in here and just copy all this. Only instead of saying create root signature, we're going to create pipeline state. And we'll copy that. And I'm going to come over here and here, bool, create pipeline state. Such. Okay. And we'll copy that. And we'll drop in here, drop that in, copy that, drop that in, and there you go. Okay, this is kind of a complex one. So let's get it set up. Create the pipeline state, which includes compiling and loading shaders. Okay. I'll talk about shaders in just a second, but let's get started with this. First of all, we want to set up some compiler flags. So let's put in, this is just a uint, so compiler flags. And we're going to set these up depending upon whether we're in debug mode or not. So we'll do a compiler if defined underscore debug. Okay, then we're going to say enable, try to use the right keys. Enable better shader debugging with the graphics debugging tools. So this will give you more detailed information as to if something goes wrong, but it's also slower. So that's why we're going to do the if defined thing. So compiler flags equals D3D compile debug. And we're going to OR that with D3D compile underscore skip optimization. All right, and then we'll do an else. Compiler flags equals 0. And of course, it keeps wanting to do weird crap with my spacing. All right, why is that giving me an error? No, what's the problem here? Oh, the end of, right. Of course. End if. See, it doesn't want to put it where I want. Stupid thing. Leave my things alone. Okay. It doesn't know what these are. And that's because we haven't told it or there's a library that we need. So let's go ahead and go back into this. We're going to go, let me see. I think if we just do the include, D3D compiler .h. That should do it, I think. Yeah, that's fine. Okay, so this is the compiler. This is for compiling shaders. And we'll talk about shaders in a bit. But yeah, that's what that's setting up. Okay. Let me see where I was. Okay, yeah. Okay, guys. I'm going to do something that you probably shouldn't do. So, just for right now, we're going to say D3D compile from file. So we're going to compile the shaders during runtime. You really shouldn't do that. You probably should compile them during compile time so that they don't slow down the program while it's running. You know, sure. So, but for right now, just to keep this easy and kind of consistent with the Microsoft help site, I'm going to do it this way. We'll change it later on. So HL HLSL. So we're going to call the file Vertex Shader, and HLSL is the high-level shading language. Okay, the shader macro is just going to be null pointer. The include, we're not going to include anything for right now. We're going to keep this super simple. Then it needs an entry point. So we're going to say VS, which stands for Vertex Shader main. Then it needs a target, which is the version of the shader. So we'll say Vertex Shader underscore 5 underscore 0, which is just 5.0. Then we'll give it the okay, stop that. Then we'll give it the compiler flags. And then see, get back my list. What are we doing next? Flags 2 is just going to be 0. The code, which is a blob. So we'll say address of Vertex Shader. And then also error. Okay. So what we're going to do here is compile the Vertex shader. Now let me talk about shader for a second. If you don't know what a shader is, a shader is just a program, guys. It's a program that runs on the GPU rather than the CPU. So the GPU can run programs just like the CPU can. These are called shaders. There's various types of shaders. The most commonly used shaders are vertex shaders and pixel shaders. You have to have a vertex shader, which runs every time you send a vertex to the card to be displayed. The pixel shader will run every time you send a pixel to the card. So if the pixel wants to draw, if the GPU wants to draw a pixel, it will run the pixel shader. You can use these programs to do a variety of effects, and they're kind of like, it's almost like they're free because they're not taking up any time on the CPU. They take up only time on the GPU, which can run them very fast. So yeah, it's a clever way of taking like the pressure off the CPU and sending it over to the GPU, which is designed to do exactly what we're asking it to do. So it can do it quickly, right? Okay. Let me just put this in so this doesn't give me grief later on. Okay, now we need the vertex shader and the error. So let's drop that in. We're going to say com pointer. So this is going to be an D3D blob. Vertex shader. And we'll do, whoops, then the semicolon. And then a com pointer. God, I cannot type today. Seriously. ID3DP blob. And then error. Okay. That should turn blue. Not sure why it's not. So that should compile. But we should get an error because it doesn't have this file. Yeah. Not all control paths return them. What are you talking about? Yes, they do. Oh. Oh, that gives me. Let's fix those. Let's see how we're doing here. Okay. Undeclared ham. Because I cannot type. I do not understand. Good Lord. Okay. We have an unresolved external in the linker. Let me just make sure Okay. D3D compile from file. This thing right here is erroring out on me because we are missing a library. So let me go find what I'm doing here. So for this, the compiler system has its own library. Pragma comment lib, comma, quote, D3D compiler.lib. And there you go. And that should solve that problem, I think. Yep, everything's fine. Now, if I run this, we're going to get an error because it doesn't have that file. Yeah. Did I not fix? Hang on a second. Yeah, I didn't do this. Okay. That's why it's telling me that. Pipeline. Okay. Let's see. We should get the right error messages. Yeah. Create pipeline state. Yeah. Okay. And the reason it's doing that is because we're missing this file. Okay. So let's create that file. Now, fortunately, this compiler has the ability to create and deal with HLSL files. You used to have to do this in like Notepad and stuff, and it was a big pain in the butt. But now they've got it in here, so we're going to add a new item, and I'm going to wait for it to load the templates. Jeez. Okay, so down here you see HLSL, and we're going to do a vertex shader, and we're going to call it vertex shader HLSL. So add. And this has its own language. This is not C. It's a high-level shading language, but it's very similar. It's kind of similar to C. So basically, you have a function. It's going to return a float 4, so 4 floats. It takes 4 floats, which is a position, and I think that's what this is saying. Quite honestly, I don't remember what the deal is with this SV position thing. So the input is a position, so 4 floats for that, and just returns that same position, right? Really nothing to it. The only thing I'm going to change here is because we used VS main, we need to have VS main in here, so I'm going to change this to VS main, and then we're going to save that. Okay, that's going to save in the same location as our program is in. I'm just going to change this too as well, just to make it consistent with what I like to do in my own programming. And there you go. That's really, I mean, that's the most basic vertex shader you can possibly have. When you send a vertex to the card, the very minimum you have to send are 4 floats, which define its position in space, right? And basically what this is saying, just return those same 4 floats back to the card, and it's just going to take that position, and it's not going to do anything with it. It's just going to draw it right in that spot. So yeah. Okay, so that should, if I'm not mistaken, it should run main. Oh yeah, we got to change this annoys me. Okay, so we got to go into project options, properties. We're going to go down to the HLSL compiler. Main, okay. Yeah. Well, okay. First of all, I'm going to change this. Shader model 4, level 9. We're going to change that to shader model 5.0. Remember, that's what we put down here. So we'll leave that. Okay. I'm also going to right-click on the Vertex shader HLSL, and we're going to open up its properties. And let me make sure I'm doing this right. Make sure I don't get this wrong. So we're going to change the entry point name to VS main. And then everything else here should be fine. Hit OK. And then that should run just fine. There you go. So there you go. We just created our vertex shader. So one of the things you can do, as soon as this thing finishes goofing off, with that, and I'm just going to drag this to the end, is you can put all your vertex shaders in here. So we've got a very, very basic one, but I can also add in more, right? Like I could go down here and create, a float for vertex shader, I don't know, and call it something else like animated or something, animation, and give it all kinds of parameters and stuff, right? And return, do some stuff in here and then return a new position. I could do all that in this file. So we don't have to just have one vertex shader per file. We can put all our vertex shaders in the same file. And all you have to do is when you come in here, right here, I've told it the name. I just changed this, right? So you can load multiple vertex shaders at the same time, all from that same file. But it has to have an entry point, and that's why we had to change that. Otherwise, it's not going to work. So yeah. So yeah, there you go. We got a very, very basic vertex shader. Now we're going to do the same thing with the pixel shader. So I'm just going to copy all this stuff right here and drop it down. And I'm going to change this so that we have something to distinguish these by. This is going to be the pixel shader. Okay, so in this case, we're just going to use the pixel shader. And we're going to change this to PS main. Same function, PS 5.0. Everything else stays the same. Except for this is no longer going to be pixel vertex shader. We're going to create a pixel shader. Okay, so let's just copy this, change it to pixel shader. Okay, so we'll create the pixel shader. Okay, so we'll do the same thing. We're going to go to project. We're going to add a new item. Let it load the template. This time we're going to create a pixel shader. We'll go ahead and add that. And I did call it pixel shader, right? I did indeed. Okay, good. Let's just drag that to the end as well. Okay, so for this one, again, this is the very simplest kind of pixel shader, and we're pretty much going to leave it just like that. So every time the card wants to draw a pixel, it's going to come in here and say, okay, what pixel do I want to draw? Right now, we're returning 4 floats. There's no inputs. So we're just going to return 4 floats. If I did this right now, it would return a white pixel, right? This is red, green, blue, and alpha channels. All ones means white. That's not really going to work for us because, of course, the window that we're using is white. So I'm going to change the green out to 0. So it's just going to be red and blue, which I think is yellow, right? Or is it green? No, it's not green. What's red and blue together? Purple? I don't know. It's different from white. That's the important thing. So there you go. So it's just going to return a pixel of this color. So we'll save that. Again, the very simplest pixel shader that you can possibly imagine. Now, again, we're going to right-click on that, go to Properties, and change. Well, that's the wrong one. We're not the pixel shader. We're going to go to Properties and change this to. I didn't change that. Cancel, 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 cancel. We're changing this to PS main. I like to put PS in front of pixel shaders and VS in front of vertex shaders. There's other kinds of shaders, like there's a geometry shader. So I would put GS for that. They're not as used. They're optional shaders. So, but there are more other kinds of shaders, but these two you have to have. Otherwise, the card won't work. So let me make sure I did that all right. That looks fine. Okay, we'll go back here, go to the pixel shader, right click on that, go to its properties and change its main to pixel shader main. And we're going to use shader model 5. That looks good. So apply that, and I think we're good. Okay. Let's go ahead and run that. Let's see how we're doing. So there you go, guys. We have a vertex and pixel shader in the assets, and that's a big deal. Even though they're by far the simplest vertex and pixel shaders you can have, they don't do anything. But it's going to be enough for us to get a triangle on the screen. We can't do anything with that triangle, at least not on the GPU. We could do it on the CPU and like animate it or something using CPU functions. We could do, but we probably won't be doing that. But yeah, so there you go. Anyway, there's our shaders. Okay, do I really want to go further? Okay, we're not done with the pipeline state yet, but I think I want to stop here because I don't want this to get too long. And the next section is kind of largish. There's only one more. There's only one more function. But I gotta fill in a big old huge description thing. Okay, yeah, guys, I think I will stop here. We're not done with this function yet. We actually haven't created the pipeline state yet, but we have created the Vertex and Pixel Shader programs. The next step is going to be to set those up so that they actually are sent to the graphics card, I believe, is what we're doing here. I think. Yeah, I believe so. So yeah, we'll set that up next time. You can, as you can tell, both Vertex and Pixel Shader are local functions, and if we exit out of here, they get lost. So there's, we do all this work to get this done, and then they're gone. So the next step is going to be, before we leave this function, to actually send them to the card so that the card knows about them. Right now, it doesn't know anything about them. So yeah. Anyway, I think what I will do is I'll drop in a to-do here. Remove runtime compilation of shaders. Prefer compile time compilation to, I think they're CSO files. I believe they're called CSO files. So right now they're HLSO files. You can actually pre-compile these into CSO files. So yeah, which we will probably be doing. It doesn't automatically do it for you. I think there's a way to do it. Well, I know there's a way to do it. I just had to have to figure out how to pre-compile these so that they're CSO files rather than HLSO files. Just spelled compilation. So yeah, we'll do that eventually, but for right now, just for the ease of getting this done, we'll set this in here. We're going to do that a lot. So I've set up a to-do list here, guys. If you don't know, you can come down here and go to a task list, and it'll tell you. Yeah, so anytime I put the word to-do in, it's going to put it in the task list. If you don't have a task list up here, you can just go to View, and there it is right there, task list, and it'll pop it in. So yeah, you can set up a task list and, let yourself know that, hey, there's stuff that we need to do that I kind of wanted to do later on. So yep, kind of a handy little function there. So useful for, that kind of thing. So let me just take a quick look. I want to examine this for just a second. Yeah, we're getting a lot of, see, D3D12. Let me try something here, guys. I don't know if this is going to work, but I used to do this in the past, I think they've taken it out now for some reason. So we're getting like errors from the IntelliSense in the library stuff, and I don't like. I'm not going to go back and recode external libraries, right? So I don't want doing this. So I'm going to try and fix that. I don't know if I can or not. I think they took this out. So warning, push, comma, 0. So basically what that's saying is I want you to turn off the warning levels, fully turn everything off until I tell you different. And then after the libraries, you then go pragma. God, learn to type. Warning pop. And that just puts it back to its regular state. Now let's just see if that works. Don't know if it will or not. Okay, this is fine. I don't care about this. Go away. Error list. Yeah, they took it out for some reason. For some reason, this no longer works. I'm not quite sure I understand why. External libraries really shouldn't give me errors or warnings. I don't know if there's any way for me to fix that. I'm not sure how to do it anymore. That used to be the way to do it. Let's see. External includes parent project warning level. Turn off warnings. Why? Let's see if that works. I think it just did it. Maybe that's how you do it. Yeah, maybe. Nope. It just comes right back up. It's so annoying. I don't even know how to do to turn it off anymore. It's so stupid. Well, if you guys know, let me know. Because I really shouldn't have to. I mean, I can turn it off by just doing build, right? Build only, and then it's fine. But I shouldn't have to do that. I should be able to get the IntelliSense to tell me if there's warnings, right? Rather than just getting them during the build. But I don't want all these external files coming up. I mean, look at this is all external stuff. And it's not my code. It's code that was created by Microsoft. So I no longer know how to turn those off. This is how I used to do it. That doesn't work anymore. For some reason, they took that out. And then this seems very reasonable to turn it off here. But it doesn't seem to work. So I don't know. Maybe if I turn this off. I don't know why. You don't need to run it. You shouldn't have to run it. Yeah, it's still there. Beats the heck out of me, guys. I do not know how to turn off external. Is it because they're not considered external? I don't know. Why would it not? Beats me. I don't know, guys. Let me know if you know. This shouldn't be happening, as far as I can tell. But anyway, yeah, I'm just wasting time now. Okay, gang. We're gonna stop here, and we'll pick this back up in the next programming episode. So I will see you guys in the next one. Thanks a lot.